Welcome to module on the nature of regression analysis. By regression analysis, we mean any sort of relationship among the variables. These variables are namely called dependent and independent variables, and based on that, a functional relationship exists. To arrive at any kind of regression procedure, first of all, we look at the scatter diagram, that is the graphical plot. Based on the graphical plot, we get a notion of correlation coefficient, which will tell us about the degree of association, and based on that, a relationship can be estimated. So in the context of a simple linear regression analysis, we basically mean that in analyzing business or economic data, we want to know the relationship between the variables, which stand by the dependent and the independent ones. Moreover, the correlation coefficient will give us some information regarding their association, and based on that, we can also examine how much one variable can be affected due to the change in the other. So in any kind of applied economic data analysis, if we want to find out the impact of advertisement expenditure on the total sales, so by changing the advertisement expenditure, we can find out the proportion of the change in sales in this manner. This boils down to the most important methodology of regression. So regression is widely used in the field of statistics whenever we want to find out an estimate of the relationship. So basically regression is a predictable method, or it's a predictive method which is actually forecasting the value of one variable based on the other. So in any regression exercise, we get both dependent and independent variables together, and based on that we can say the predicted or the response variable. The value of the dependent variable also depends on the value of the independent variable, and vice versa the things work on. So this boils down to the important question which says that explain the concept related to the nature of regression analysis. So to give a response, we can say that firstly the correlation coefficient, which has to be computed at the beginning, which will give us certain information about the nature and the extent of the relationship. The nature means whether x and y are directly proportional or inversely proportional, and the extent will tell us the percentage of the correlation coefficient, whether it is more than 50% then strongly correlated or less than 50% weakly correlated. Moreover, by the regression analysis, we also want to know how much one variable is affected by the other, and that is how the procedure will come up. This also boils down to the most important steps that are involved in the simple regression analysis. This is basically looking in terms of a linear model. So by linear model, we mean any kind of straight line that can be fit out of the given data. So the type of the relationship that is concerned between the two variables is linear. For example, it has a constant slope or it has a fixed intercept, and that is what the linearity means by. So we plot the variables and we want to find a straight line graph. So we have an example here. That is, a car manufacturing company is founding that the dollar volume of sale is dependent on expenditure, and so we make an equation where y stands out to be the dependent variable, xi stands out to be the independent variable. So here y is the volume of sales and xi is the advertisement expenditure, alpha is the constant intercept, and beta is the slope. Based on this relationship, we have an error term which is EI. So this error term will be computed in such a manner that sum of the squares can be minimized in that case. This also boils down to the most important method that is being followed in any regression exercise. The method says that alpha and beta are the unknown parameters. So by parameters, we mean that we have a population size of capital N. From the population size, small sample is being collected, which is small n, and thereby the characteristics of the population are the parameters which are always unknown. So they are now estimated on the basis of the sample observations, and that is what we can get alpha hat and beta hat. So for this procedure, we basically look at the error term, which is EI, and thereby this EI is basically random or stochastic. So it has a zero mean and a constant variance, which will capture the uncorrelated factors or the unobserved factors influencing the dependent variable. So this above function is a parametric form which specifies a different definitions for the parameters alphas and beta. So the parameters are unknown, and based on that we can estimate the equation as yi hat alpha hat plus beta hat xi. So alpha hat and beta hat xi are the population parameters which are estimated on the basis of the sample. This boils down to know that how can we get an depth understanding of this alpha hat and beta hat. Basically, when y hat, alpha hat and beta hat are the estimator of the dependent variable and the unknown parameters, we can say that y hat is an estimate because y hat can be calculated on the basis of the observations. The error term is always the difference between the estimated value and the observed value, because the estimated value will be taken up in case of a graph plot and the observed value is based on the given observations. So we go by the term residual or the error, which is the deviation between the observed value and the estimated value, and thereby the value of the error should be as less as possible, because then only the methodology will be more robust. So this can be done if we square up the errors, and as we know that when we square up, some of the positives and some of the negatives will equate each other so that the margin of the error is not large. So this takes care of the expression of EI, which is one of the valid expression to proceed with this method of least squares, which is applied in the estimation of the parameters alphas and beta, where we say EI that is equal to yi minus alpha hat and minus beta hat xi. So this yi is the observed value and the predicted value is the yi hat, and we want to find out the deviation to be as less as possible so that the method of least squares can be easily applied. So thereby we can invite a question in this regard, that set up a regression model and explain the variables. So whenever we are setting up a regression model, we say that it is empirical specification, where yi will be dependent upon xi inclusive of an error term which is random. This random term has a zero mean and a constant variance. Based on that, we formulate an error expression, which is the difference between the observed value and the predicted value, and we want to minimize these errors such that the regression model can give good predictors for alpha and beta, because this alpha and beta are the population parameters which need to be estimated on the basis of the sample observations. So alpha hat is an estimate of alpha and beta hat is an estimate of beta accordingly. So this basically gives us a kind of a relationship we want to study. So once we get a notion of y and x existing together or y and x affecting together, we basically have got the estimate of alpha and beta. So the question arises that how can we mention or give a good explanation terminology to this relationship, and that is none other than regression exercise. So basically in science we frequently measure two or more variables on the same individual. Like for example, the object is being studied under two different experimental conditions. That is also a regression exercise. Also, we want to explain the nature of the relationship between the variables, like how x and y are related. Either there is a cause-effect relationship or there is a functional relationships. So in either of this case, we go by a mathematical relationships that says predicting one variable corresponding to the value of another variable. So whenever we are predicting y, then we are basically taking up different values of x for which y will change. So y is referred as a dependent, and that is also called a response variable or a predicted variable, and x is referred as an independent variables or explanatory or the predictor variable, because x is influencing y and x can take any value of the choice. So this boils down to some of the real life examples where we can apply the notion of regression analysis. The first of all regarding the time needed to fill a soft drink vending machine. So here we observe that this time can be captured in terms of hours, which can be basically considered as the independent variable, and the filling it up is considered as a dependent variable. Next one, the example that comes up, number of cars needed to fill the machine, or the intensity of light in an incubator, the age of the tractor. All these are examples from the fields of science, experimental studies, where we can also explain how y and x are related to each other. So in all this statement we can say y is a function of x. This also takes care of some of the control variables which can be dealt or modified in the study. For example, where the control variables are there, then the researcher can have some kind of freedom to deal with them, either to include or to exclude. Or there may be some variables where this control variable is not required. So this is basically coming up with the notion that some examples of regression model can also be set. So in all these examples, we actually examine what type of relationship comes in by the cause and effect. For example, if we say that smoking is injurious for health, so any kind of health hazard is dependent upon any kind of irregular lifestyle, that's a cause and effect. Or it can be a functional relationship. For example, if the price of the commodity increases, quantity demanded will fall. So quantity demanded is dependent upon the price, which happens to be a functional relationship. So two-way relationship is also possible, which can also be captured by the regression time to time. So that is why the regression analysis can be overviewed. Now we come up with a kind of a scatter diagram so that we can get a kind of a fitted line, and based on the fitted line we can argue whether the regression exercise is robust or not. So this boils down to a practical example. An operations supervisor measures how long it takes of a drivers to put 1, 2, 3 and 4 cases of soft drink into a soft drink machine. And in this case, the levels of the x are 1, 2, 3 and 4. So this is a very discrete time period or a discrete variable x, which takes up the values 1, 2, 3, 4, which is basically regulated by the operations supervisor. So she might repeat the measurement a couple of times at each level of x, and thereby a scatter plot can come up. So in this particular scatter plot, we are now fitting a linear segment, just as it's shown in the slide. So this segment shows that all the points on the segment are the best fitted points given the loading time and the number of cases. So loading time is dependent upon the number of cases, which are taken as 1, 2, 3 and 4. However, we observe in the particular slide that this particular scatter point or this particular coordinate is very much on it or very much near to this fitted line. So this is the best fit compared with the other two, which are also lying very much close to this base fitted line. So this thereby says that any kind of regression exercise where the fitted line is said to be the best fit, then the accuracy of the methodology is determined. That means the methodology of the least squares is more accurate because all the scatter plots are very much close to this fitted line. And that is what we observe in this particular case. So this has basically been explained whenever we want to find out whether the regressive framework or whether the regression result can give out any kind of linear relationship, and if there is a linear relationship, how the plots are being decided. Here we consider another important fit which comes up with an experimental data of a forestry graduate which makes a wrapping paper out of different percentages of hardwood that measures its tensile strength. Here also we observe that the points which are very much closer to the fitted line, and thereby the best fit can be evaluated. So this goes back to the very good question on it, which says show graphically the relationship between y and x. So thereby the scatter plot can be done, and based on that we can even go for fitting a line, and we want to say whether the points are closer to it or not to it. This goes back to the notion of functional relationship. So by functional relationship, as it is said in case of any kind of regression exercise, is what is the association between x and y? That comes up as the basic question. Then how the change in y can be explained by the change in x, and thereby what can be the other functional issues of x and y. So when we go by the functional relationship, we mean y is a function of x, and thereby we can find out the magnitude of the change in y due to the change in x. So this goes by the slope coefficient, or this goes by the fitted line which is closer to the data or the scatter points, and thereby the B1 comes up. So this B1 is given by change in the perpendicular due to the change in the base, and thereby we can explain any sort of functional relationship between it. This also boils down to the linear relationship among any kind of variables. So here we find out y is cholesterol, which is dependent upon the age. So a kind of an estimated relationship can come up where y is a function of x, where b0 is the constant intercept and b1 is the slope. So based on that, we have the slope coefficient, which is given by perpendicular and base, given by the dy dx, and thereby we can explain how x and y are related with each other. So the slope can be given by the b1, which is change in y due to the per unit change in x, or any kind of magnitude that comes in. This also boils down to any kind of nonlinear relationship that can also exist. So in the other discussions, in case of a regression, we always stick to a linear relationship, but in overall sense, the relationship can also be nonlinear. So thereby we go by polynomial relationship, where y is the crop yield and x is the pH factor. So here we observe y, which is the crop yield, dependent upon x, which is the pH factor, and x is also considered in the square form, so that b2 is the quadratic coefficient. So b1 is a linear coefficient and b2 is the quadratic coefficient. Both of them are existing together. So thereby we can say any kind of curve which comes up, which shows a peak and thereafter falls, and that is how the best fitted regression, linear or nonlinear segment can be plotted. So this basically goes into the discussion that how the x and y can be related with each other, and how we can explain the magnitudinal change in y due to the change in x. And that is what is discussed in this particular diagram. So show graphically the slope between y and x, or how the slope comes up very much intent in it. We see that dx and dy are the two measurements, and thereby the slope can be captured. So what are the concerns regarding any kind of regression exercise? The first concern is this, that the proposed functional relationship will not fit exactly. So exact fitting cannot be done. There can be error in the measurement because the variables can be measured in different units and which may not be uniform, or there can be inadequate specification. That means most of the effect of dependent variable is due to the error term. So independent variable is explaining much less percentage than the error term, because in error term all the unobserved factors are included. So this relationship is not truly unknown, but when we assign the values to the parameters of the model, it comes up. So we observe that y is function of x plus epsilon, where this epsilon is the error, or it is basically the random variable, which will take care of this specification part or specification error. So when we refer to any kind of regression analysis, we have the following steps. First of all, we examine the scattered plot of the data, whether the data points are linear, whether there is any kind of transformation. After that, we estimate the model using the method of least squares. And then we want to find out any kind of justification regarding the testing procedure. That means whether a linear relationship is followed or whether a nonlinear relationship is being followed. And finally, we also take care of the systematic inadequacy. That means the relationship is not best fit in a linear framework, but is there any scope to explore on the nonlinear framework, or the specific data points proposed to follow any kind of relationship. So this basically comes up with a kind of the steps which are involved in functioning of any regression analysis. First is scatter plot, then we look after the linear plot. After that, we want to study whether the dependent and independent variables having any relationship. We go by the residual series, we minimize the sum of the residuals or the errors, and thereby the estimates are considered. So this actually belongs to the procedure of least squares, where again we basically discussed the minimization of the errors, and that is how the slope coefficients can be estimated. So in this particular module, we basically give up an orientation of a regression procedure where the regression crops up from the correlation or from the scatter diagram. Then we discussed on the functional forms, whether we go for a linear or a nonlinear structure. For that reason, we go for an empirical relationship which takes care of the error term. And finally, to estimate in a linear version, we go by the method of least squares. That is, we minimize the sum of the errors to get the best estimates of the population parameters. So that is how regression is widely applied in the real life data to estimate and also to forecast the future values in all fields of science, social science, and also in the field of other sociological and marketing and management studies. Thank you.